This is another example of finding transfer functions off of block diagrams. This is a little complicated. Well, yeah, we have a disturbance here function, and we have two feedback functions here as well, and finding the CS over this is not straightforward at all. So let's go ahead and try this one out. So what I typically do is, of course, I assign some variables or whatever. So let's call this E of S, the function coming out of the sum from here. Let's call that E of S. Call this let's not use anything here because it's whatever it's gonna be ESGC anyway. Let's see what else we can call. So let's use this one and call it F of S, the function over here, and here, and then let's call this FG, another variable. Let's use B maybe. Okay, let's use B of S. Okay, so E of S is equal to what? E of S is equal to RS minus, so we're setting up our equations before we even replace anything. So E of S is equal to RS minus CS H2. C of S H2. Okay, what else do we know? F of S. What's F of S here? F of S would be this function over here. So ESGC right, minus, so ESGC minus the function over here, B of S H1. Okay, right? So B of S is what? B of S. B of S would be B of S would be the function over here plus ds multiplied by G2. So we can put G2 out. G2 out, ds plus H1. This is H1. Hold on. H1 over here, right? F of, wait, what was that again? So F of S is coming in minus H1 B of S, right? Okay, so B of S is then equal to G2 multiplied by ds plus the thing that's coming here, FSG1. F of S G1. And that's pretty much it. So C of S is then, let me put that over here, CS is equal to the straight path, that's a forward path, which would be this times this So C of S would be, since we called variables, we can just multiply these two together. So that would be P of S G3, but it's a straight path. But notice that B of S is in terms of G2 and etc., so we don't have to rewrite the whole thing, with the summation and all the stuff we can just worry about here. So that's the reason why assigning variables in the summation output is actually valuable. Okay, so we can go ahead and replace whatever we know now that we have set up everything. All we need is just some math, replacing and expanding, etc. So C of S, let me put that over here. Okay, so C of S is equal to BSG3, but what's BS? G3, so BS G3, BS is G2, D of S minus G2 F of S G1. So that's BS, right? And we can multiply all of this by G3. I mean G3. So we can expand that before we even replace anything. So I have multiplied by G3, so that'll be G2 G3 D of S minus G1 G2 G3 F of S. Okay, so what do we know from here? What do we not know? F of S. So we can go ahead and replace our F of S again. So C of S is G2 G3 D of S minus G1 G2 G3 F of S is ESGC minus minus BS. Shouldn't be BS. Shouldn't have another variable there. Let's see here. Hold on. For F of S. What do we have for F of S? F of S is the thing coming in. Yeah, it is correct. Okay, I guess it's gonna be long. Okay, wow, this is gonna be huge. C of S is equal to let's go ahead and replace E of S and then replace BS later. B of S. So G2 G3 D of S minus G1 G2 G3, all of this together. Let's expand. G1 G2 G3 GCES GCES, so I have a minus sign. Oops, yeah, plus, then it'll be plus G1. Let's do this. G1 G2 G3 H1 BS B of S. So I did my expansion. I can go ahead and replace my E of S and then B of S once again. So C of S is equal to G2 G3 D of S minus G1 G2 G3 GC. And what was my oops, what was my E of S? E of S is RSCSH2. RSCSH2, so I can replace that. So that'll be ES would be RS minus CS H2. So that's my ES plus this. Now I'm not going to replace BS again. I'll continue with this first. I hardly believe that they're gonna give you this in the FE, because you only have 4 minutes in the afternoon anyway to solve one problem, but it's a good practice. It's probably going to be a much more simple problem, but at least if you know the fundamentals and what to do, then you shouldn't have any problem at all whatsoever with any other problem. So I was left here with G1 G2, hold on, G1 G2 G3 H1. I can go and replace my BS once again. I can derive BS from here anyway. BS was, let's see, let me do it here. BS, let me use a different color. Let's use yellow. I never use yellow. BS, in terms of everything, would be G2 DS plus, not plus, minus rather, minus G2 DS G2 FS G1 G2 FS G1, and then G1 G2, well, let's say G1 G2, and then FS is, oh, hold on, did I do that? Hold on. Okay, hopefully it's right. Okay, whatever. So, okay, let's continue with our method. So G1, where was I again? Where was I? So G2 D of S, G2 D of S, FS. Okay, so I'm replacing FS. Okay, so G2 D of S minus G1 G2 F of S, and F of S is E of S GC minus B of S. I was wondering why the BS came back, because that's exactly what I'm trying to get, but that's not an issue. B of S, I guess I can take him out. It's my inside voice talking right now. Oh. Okay, I'll just solve without talking too much. So G2 DS, G1, G2, GC, ES plus G1, G2, H1, BS. This is not part of it. Okay. So the only thing we need to replace here is so B of S is actually the big one. Remember from here, from the block diagram, BS is like the whole thing coming out of every single thing. That's why it's long. So, but let's continue here with our logic. So G2 DS minus G1 G2 GC ES was what was ES? RSCS. Okay. RS. I'm here. Minus C of S H2 I'm here, so I'm not going to touch the BS again. This is longer than I anticipated, but the solution that they gave in the solution that I'm in the problem that I'm using, I don't like that solution at all. I don't understand how they did it, but I want to use a logic that I actually understand, even if it takes long. G1 G2 H1 BS. So now I can expand. This is the final expansion, I believe. So G2 DS minus, I'm sure I made a mistake somewhere, but you guys, if you're watching this, make sure you peer check me as much. So I have G1 G2, okay, G1 G2 GC R of S plus plus G1 GC G1 G2 GC CS H2. So let's say H2 CS. Okay, so I expanded this. Now I have plus G1 G2 H1 BS. So my BS would be a fraction. If I put the BS's that sounds really good. BS's. So B of S. So I will have 1 minus G1 G2 H1. This is equal to the whole thing, and therefore BS would be, B of S would be this whole fraction. Oh wow, this is humongous. So this is G2. I'm wondering if I actually can pull this off. It's long. Minus G1 G2 GC R of S. I'm already tired. G1 G2 GC H2C of S over this 1 minus. Alright, now that we have our B of S, we can go ahead and plug it in to this equation. Oh wow, this is gonna be long. Okay, so I probably won't finish this because then it's gonna take me hours, and they're most likely not gonna give us this in the they're not gonna give you this in the FE because it takes longer than 5 minutes. But I just wanted you to see the logic here and how to derive it from a complicated, obviously a complicated block diagram. But in the exam, it's not this complicated anyway. But sometimes it can get tricky. So my BS is, I'm just replacing my BS with whatever I have for my BS. So that'll be something, the long equation, remember? The yellow thing. Here, something over something that we had for BS. Now, as you can tell, CS over DS is what I need. In the BS, in the B of S expression, I'm sure I have a D of S somewhere. So all you need to do is put expressions together. Yes, I have a D of S here. Put the expressions together, the like terms together, the C of S together, and then divide. And the answer that they have is, let me write it down. So if you have time, you can finish that up. I just wanted to show you. Typically, we use a different color. Let's use purple, my favorite color. So they have CS over D of S is equal to G2 G3 over 1 plus G1 G2 1 plus G1 G2 times H2 oh, I'm sorry, it's H1 actually. H1 plus G what is this? GC G3 GC G3 H2. That's it. So if we because there are a lot of like terms over here. See, you could see here the G2 G3 of DS already, and we are we have CS over DS. So CS, there's another expression for CS that I can see over here. Now I don't know what to do with the RS's though. Maybe they ignored it. Let me see here real quick. Oh, okay, ours was the input anyway. So that's probably one expression out of many, because here this is a disturbance and this is not output over input, so it's probably ignored down the line somewhere. But that's pretty much it. So if you know of any other way to do this, simpler way, then you can write it down in the comment section, an easier way to approach this problem, because the solution that they have in the book I'm using, my professor gave me in his book, but I don't like that one, because what they did was they ignored the summations and then solve for that one by one, which takes long as well as this one. So either way, either method you use is going to take long anyway, but that's not the point. The point here is to know how to approach it and derive it. But I don't think they will give us this in the exam anyway, because it takes too long. But if you understand how to derive it, essentially that's the fundamental, and you can solve any problem. As long as this is big problem, you could see that the steps are pretty easy, right? It's logic, going back and forth and replacing and being extremely careful with whatever you have. So let me know if you have any another approach that you would rather use to get the C of S over D of S. Thanks.